Well, now we're doing the review for section 4-3, and it says a single bacterium divides every 0.25 hours, or every quarter of an hour, to produce 2 complete bacteria. If we start with a colony of 2,000 bacteria, after T hours there will be A of T, which equals 2,000 times 2 to the 4t, which ultimately becomes 2,000 times t to the 16, or excuse me, times 16 to the t power, times 16 to the t power. And we have to find A prime of 3. Well, let's find A prime of t first. And so the 2,000 doesn't change, times, and you know by the rule for taking the derivative of a power function, that this becomes 16t ln of 16. And when we run that through the calculator, oh, I beg your pardon, we have to find A prime of 3. And when we run that through the calculator, replacing t with 3, I get 22,713,046.8. But we can't have a fraction of a bacteria, so we'll disregard that, and then our final answer is 713 and 046 complete bacteria, and we're done with that. Well, now we'll do question 2, and what we have to do here is find the derivative of f of x equals the quantity f of, or 5x minus 1 times the quantity 4x squared minus x to the 5th. And we'll use the product rule. We don't want to multiply all that stuff out. So f prime of x equals, and we'll take the derivative of that guy, and the derivative of 5x minus 1 is 5. And that's going to be times 4x squared minus x to the 5th. Now plus, and now we'll hold 5x minus 1 constant and take the derivative of 5x minus 1 of this thing, the second factor. So the derivative of 4x squared is 8x minus, and the derivative of x to the 5th is 5x to the 4th by the power rule. So let's multiply this stuff out and combine like terms. So 5 times 4 is 20, x squared minus 5x to the 5th. And plus, and let's see, 8x times 5x is 40x squared. X times x is x squared. And 8x times negative 1 is negative 8x. And minus 5x to the 4th times 5x is going to be minus 25x to the 5th. And minus 5x times minus 1 is going to be a plus 5x. Now let's gather up like terms. And we always want to lead out with a positive. So notice this 40x squared plus 20x squared, I get 60x squared. And then we have negative 5x to the 5th and minus 25x to the 5th. That's minus 30x to the 5th. And we have a minus 8x and positive 5x, and I would say that's going to be minus 3x. And we've got it. We're done. We have one more to do. Yes, so now we'll do number 3, and we have to take the derivative of this, so we'll use the quotient rule. So we have y prime equals, and now the quotient rule says square the denominator. Okay, we'll do that. Now, hold the denominator constant and take the derivative of the numerator. So that's going to be 3x squared. Now, put a minus sign here. Hold x cubed constant. Take the derivative of minus 3x squared. Well, the derivative, or 2 minus 3x, I beg your pardon. And the derivative of this, by the way, we hold x cubed constant, and we take the derivative of this thing, and we just get a minus 3 out of that. So now let's expand that, and downstairs we're not going to expand that. It's a done deal. But we might have some like terms upstairs that we have to combine. So 3x squared times 2 is 6x squared. And 3x squared times a minus 3x is a minus 9x cubed. And here we have a negative x cubed times some negative 3x is going to be a plus 3x cubed. Now let's combine like terms. And nothing's happening downstairs. We square that. And like terms, let's see, 6x squared, no other like terms there. But we can combine these 2x cubed terms and we get minus 6x cubed. And we could factor out a 6x squared, but if we did that, nothing's going to divide out, so why bother? We're done right there.